Okay, good morning, everyone. Thank you. Esmeralda, questions about the homework before we get going? So I give you a few seconds to gather your thought and ask me questions about the homework. Okay. All right, so today we're going to finalize exponential and we're going to start the chapter 4 logarithm, which will be the last, of course, the last thing we're going to do in this class. So before I do that, I would like to do 2 problems from the worksheet, and you guys, it's up to you to finish the rest, and 2 problems from section 3.2, and then I will move on. Okay, so last time what we did, and I'm going to do one review of that. Last time what we did 2 things. The first thing we did is that if you have an exponential function and you have 2 data points, so you don't have the rate, the question is how to find a formula. Okay, and Isabel, no, the quiz is on Tuesday. The quiz is on Tuesday. Usually I announce the quizzes, so the quiz is on Tuesday. All right, so I'm going to do number 2 from the review. I mean, from the worksheet that I posted on Brightspace. I don't know if you guys looked at it. So here is my question. Okay, sorry. So that's the problem that I posted. Let P of T be the population of a country in millions. So this is the population in millions. T years after 1990. So 1990 is when we started, not when we started. Yeah, 1990 is when we started checking the population. And so let P of T with population with P of 7, it means after 7 years, the population is 3.21. After 13 years, the population is 3.75. Assume that the population grows exponentially, find a formula for P of T. Okay, so that's the problem. So we have an I'm trying to use focus. Right. So we have a population and what's given to us. So that's really what we have. So that's time and that's the population. So we called it P of T because P stands for population. And at T equal to 7, so P of 7 equals 3.21, it means if T equal to 7, the population is 3.21 million. So that's the population, 3.21 million. If T equals 13, that's 13, the population, so 7, 13 should be somewhere in here. The population is 3.75. So grew a little bit. So that's 2 points. And assume that the population grows exponentially. So that's not a linear growth, that's an exponential. So this is going to curve like that. That's my population. So I have 2 data points, 13, 3.75, and I have 7, 3.21. Okay, so we measure the population at T equals 7, T equals 13, and that's what we came up with. And the question is, we need to find a formula for the population. So that's an exponential, we need to find a formula for it. So I will take a sheet of paper and we'll do it. So what we have in this scenario, it's like along the line we did last time. So just one more problem along those lines. So we have time and population. At T equal to 7, the population was 3.21. And at T equals 13, the population was 3.75. And the question is, P of T is exponential, so it's not a linear growth. And then the question is to find a formula. Right. Okay. So exponential tells me that the formula has to be the form A times a certain B to a power T. And we need to find A and B. So you guys help me out. How do we do this type of problems? So we have two data points, so we have two things, and we have to find the A and B. So we know that we're going to use this info, and we're going to use the other info. Okay. We would like to do this problem kind of fast, so please help me out. How shall I do that? Okay, Esmeralda, are you with me? No, she's not. Okay, who would like to lead? Who remember how we do that? So population at 7 is 3.21. Means we plug in 7 here, and we get 3.21. And I plug in 13 here for B, and I get 3.75. So the question is now I need to use those equations to solve for A and then to solve for B. All right, how do we do that? We divide them. So we divide, we take the highest power here to make the math easy for us. And I said this is equal 3.75 divided by 3.21. And the goal, as you remember, is to get rid of the A's. And this will give me B to the power 13 over B to the 7 equal 3.75 over 3.21. And now, B13 over B7. This gives me B to which power? Please, I want answer on chat. I don't want to keep talking to myself. B to the power 13 over B to the power 7 give me B to the power 6. What is the 6 coming from? Ricky. Three 13 minus 7. So we take away the power. Absolutely. B to the power 7 equal. Now let me evaluate 3.75 divided by 3.21. I'm getting 1.168. That's B to the power 7. So what's the value of B? Who would like to give me the power of B? What's the value of B? Evaluate it, put it on chat, and tell me how you get it. What's the B? How can I get the B? I have B to the 7 equal 1.1 that. How do I get the B? Oh, B to the 6. What did we do? Oh, sorry. Yes. Okay, my apology. So B to the 13 over B to the 7 is B to the power 13 minus 7, which is B to the 6. So what's going to be my B? 1.168. So basically, we take the 6th root of 1.168. That's simple. And then this would give me, Naki is giving me 1.168. Now, what's the answer? So what's the 6th root? .026. That will give me the B. Okay, so now I have my B. Now I'm going to find my A. All right. To find the A, I have two equations that I can use to find the A. Now that I have the B, I can either use this equation or that equation to find my A. So I'm going to use the first one. There is no reason why I could have used the other one. So find A. So we know A times B to the 7 equal 3.21. But B is 1.026, so I will have A times to the power 7 equal 3.21. So now I need the A. So to find A, I have to divide by this term. And I find my A. And how much do we get? Do the math with me so we can finalize this problem. Anybody getting any answer? Remember, it has to be less than 3.21. What are you guys getting? Anybody? Aiden, Kale, are you doing it? Okay, anybody got the same answer? $2.68. I think I will. You're absolutely correct. So now I have a formula for the population. So my population now is, so I had two data value. I know it's exponential, but that's my population. To the power t 1.026. That's a formula for the population. Now that I have the formula, because I was able to track the population and count it in a way like a census, now my question was the following. What's the initial value and what's the growth rate of the population? So what is the initial value? So now this is the formula for the population. So the initial value, it means in 1990, the initial value that is in the year 1990, because that's when we started the counting, the population was 2.68 million. That's what we're starting with. So on the graph here, that's the starting point that we did not have. We did not have the initial value. And okay, now, what's the growth rate? I want all of you to give me the growth rate. So this is a population which is growing at the same rate every year. So at the same percent rate every year. What is the percent rate? According to what we found, that's really the idea. We did not know how fast, by what percent of population. That's the growth factor. So here we have B, which is the growth factor, is 1.026. And we know that the B is 1 plus the growth rate. Okay, it means the growth rate is going to be 0.026, which is in percent 2.6%. So that's a scenario of a population which is growing at the rate of 2.6% per year. So we did not know the rate in this problem, how fast, by what percent the population is growing. We knew two data points. We used them to be able to figure out the percent rate. Okay, you guys should finish the worksheet for your quiz next week. Now, number 3, I care a lot about number 3. I'm going to read it, and I expect you to answer the question. So last time we talked about linear versus exponential, and this problem also talk about one aspect of the difference between them. So I'm going to read the problem. I'm expecting answers from you. A population has size 5,000 at time t equal to 0. So it starts with this. Was t in years. Let P of t be the population in the year t. So I'm talking about a population that started with 5,000. Question number 1. If the population decreases by 100 people per year, find a formula for P of t. First, question number 2. If it's decreasing by 100 every year, what kind of model is the population? In other words, is the population decreasing linearly or exponentially? Question number 1. And then I want a formula. I give you a minute to answer the question I'm going to ask you guys. So I want you to read it very carefully, and I want a formula for P of t. intuitively, I want the graph also. How do you think the graph will look like? Okay, who's ready? It's very easy questions. The population decrease start at 5,000, decrease by 100 year. Is this linear or exponential? It would be decreasing linearly in this case, right? Absolutely correct. This is linear because I'm telling you every year by the same amount, 100. Every year by 100. So this is an absolutely linear. That's absolutely linear because it's by the same amount every year. It's not by the same percent. It's exactly by the same amount. So what's going to be the formula here? So the slope in this case, because you can, is minus 100 because it's decreasing by 100. So 100 people per year. So the formula would be the initial minus 100t. Okay, so this is absolutely linear because it's by the same amount every year. Every year we're going down by 100. All right, B. If the population decreases by 8% per year. So it's not decreasing by the same amount. It decreased by 8% the first year. So 5,000 go down by 8%. Now we have a new population and then again another 5%. Is this exponential or linear? This is an exponential decay because it decreases by 8%. It decreases. So now what's going to be the formula? So now the population is the initial times b to the power t. And what is my b? Since we have a decay by 8%, it means the growth rate, we have a negative growth, that's my negative here, of 8%, which is minus 0.08. So my cofactor is 1 minus 0.08, which is the 0.92. And in this case, the formula would be 5,000.92 to the power 2. Okay. So again, we're comparing two different decay. The first decay is the same amount every year. That's where the linear come into the picture. The second decay is by 8% every year. So we start 5,000, we go down by 8% of what we started with. And then we have a new value here. We go by 8% of a lesser amount. And 8% of a lesser amount, that's a typical exponential decay. So we have to be very careful with a linear versus exponential. Linear, the same amount. The exponential by the same percent every year. So it's not the same amount every year. All right. So this is for the worksheet. I will do 2 problems from 9.2, which is as we, one of the things. So linear, again, linear versus exponential. Linear versus exponential. So last time we saw that if f of x is linear, then when x increases by 1 unit, okay, so f of x, let us say mx plus b, for example, then m is added to the y value. So we add m to the y value. If it's exponential, b to the x exponential, it means when x increases by 1, the output, f of x, the y value, is multiplied by b. Okay, so that's what we saw last time. Okay, and So in the exponential, x increase. In the linear, x increase by 1. M, the slope is added. In the exponential, the y value is always multiplied by b. So we're going to do two problems from where I start. So section 9.2, I'm at 3.2. Okay, I'm going to do the following problems. I don't know if you guys did them. I doubt it. So I will do number 5. And then I will do another one. I'll let you do the other one. Number 5 is the following. We have x, f of x. And we have a bunch of values for x. So this is a 2, and that's a 5. That's a 3, and that's a 10. That's 4, and that's k. And here is the question. Assume f linear. F linear. The question is to find k without finding a formula. So this is a function. It takes 2 to 5, 3 to 10. So basically that's an increasing function. It takes 2 to 5, that's a point. And it takes 3, so that's 2 to 10. So it's linear. Scenario number 1 is linear. And the question is, find k without finding a formula for f. I give you 30 seconds to give me k. 15, Taylor tells me 15 because. Taylor, speak up. Taylor, can you talk or not? Adding 5. When this is increasing by 1, we're adding 5. Increase by 1, we're going to add 5. So k is going to be what we had, plus 5 equal 15. Okay, now exponential. So let's assume f exponential. So I'm going to draw the picture again and tell me what to do. So the same picture means the same data, but then everything now it's going to change. X, 2, 3, 4. F is 5, 10, and k. And f is exponential. I want k. So in the picture here, 2 to 5, 3 to 10, but the function is not linear, it curves. So the question, so this is a 2, this is a 3, and the question is for k. What's k? All right, back to you. Okay, some student give me a 20. Anybody else? Remember, exponential, we multiply by the same factor. That's the b. The b is what we multiply by when x increases by 1. And here I'm going to take x increased by 1, x increased by 1. So what's happening from here to here? From 5 to 10, we're going to multiply by 2. So going from here to here, I multiplied by 2. The exponential, I multiply by the same number. So from here to here, I have to multiply by 2. So my k is going to be 2. That's basically the factor. That's the growth factor times 10, which is equal to 20. Okay, so from 10 to k, we have to multiply by 2. So in exponential, we always multiply by the same multiplier, which is the growth factor. Okay. Right. I'm going to do another problem, and please work so you can get. This is not hard stuff. Usually students do well in it. So I'm going to do number 7. It's slightly harder, but not much. Okay, so this is my function. And it's 2, 3, 4. And the output are 10 and 4 and k. And the question is both. Assume f is linear find k. Without finding a formula. Okay? I want an answer, please, very quick. Anybody else? I need more than one because I don't do those problems. I want you guys to tell me what you get. Anybody agree with your classmate? Okay, okay, all right. So we agree on -2. Let me see. If linear, it means when we increase by 1, which is that's what this whole problem is increasing by 1. Why? From 10 to 4, we go down by -6. Means from here to here, we should go down by -6. So this tells me it means that 4 minus 6 is going to give me k. It means my k has to be -2. Absolutely correct. Question number 2. What happens if f is exponential? So I'm going to, again, the same problem, the same data, but it's an exponential. Two, 3, 4. And f is 10, 4, and k. And the question is, assume f of x is exponential. What is the k? This is a little bit harder, and I want an answer. So one of your classmates gave me 8/5. I have no idea where it's coming from. I'm not saying it's wrong, though. I want other student. So the question you're going to ask yourself, if it's exponential, it means when x increases by 1, the y will increase by the same amount. So you're going to ask yourself, it's going to be multiplied by the same amount. So you're going to ask yourself, what are you going to multiply by? Oh, that's the full answer, sorry. What you're going to multiply by, and then we find a k. So from 10 to 4, what do you multiply by? So the question is that if you have a 10, what do you multiply by to get a 4? That's how we're going to find the multiplier. What should you multiply by to get the 4? So according to the picture, what I should multiply by, this is 4 over 10. Or if you want, 2/5. So the question first is, what is the b? Basically, I'm after the b. What is it I should multiply by? So I ask myself, 10 times what will give me 4? So I solve for it. It's 2/5. So this here should be 2/5. Okay. So what I should multiply this, once I figure out the 2/5 here, I'm going to say, so this we should multiply by the same one because x is increasing by 1. So it's going to give me, it means that k should be the previous value, which is a 4, multiplied by 2/5. It means it's 8/5. And that will be my k. All right. The goal of this problem is, again, to emphasize how exponential versus linear work. While in the linear, we add the same amount. In the exponential, we actually multiply by the same amount. Now, I urge you to finish the homework for next time, because if you don't really do them, you're not going to learn this material. Okay, so the last thing I would like to do is talk a little bit about the graph of the exponential one more time, and then I move on to the new chapter. So the graph of the exponential function. I talked about it in an informal way, but now let us formalize it. So, which is section 3.3, the graph of the exponential. Okay, so the formula is for an exponential function is f of x equal a times b to the x. And we're going to assume in our scenario that a is positive. We're going to assume that a is positive. But let me say a little bit about b. b is also positive. why a negative b doesn't make sense. So why we cannot have something like that. Minus 4 to the power x. The reason we cannot have b is negative because if I put f of x equal that, then this does not always make sense. Because if I take f of 1/2, I will have this to the power 1/2. It means 2 times the square root of minus 4, which doesn't make sense whatsoever. So the growth factor always has to be positive. So if you put a negative growth factor, you say I'm doing something wrong. The growth factor has to be always positive. It's never a negative number. Now the graph of the exponential, we're going to take two graphs and then generalize the idea. So suppose I take the following. F of x equal 3 to the x. I'm going to take a to be 1. So here a is 1, the initial value, because at 0 I have 1, and the growth factor is equal to 3. So how's the graph looks like? This is my graph, and I'm going to take some values here. Okay. X, 3 to the x. All right. Okay, I'm going to take positive and negative values for a change this time, because I always do positive. So I'm going to take 0, 1, 2, and minus 1, minus 2. All right? At 0, we have a 1. At 1, it's 3, which is we multiply by 3. That's how this one works, because that's the growth factor. At 2 is 3 squared, which is 9. Again, we multiply by 3. Okay, so we're making the numbers bigger because we're multiplying by 3. At minus 1, let us see what it is. It's 3 to the minus 1, which is 1 over 3. So let me start drawing those points. This is the 1. After 1, it's increasing. It's multiplied by 3. At 2, it's multiplied by another 3, so it's really going up. What is at minus 1? At minus 1 is 1/3, so it's right there. At minus 2, it's 3 to the minus 2, which is 1 over 3 squared, which is even. So at minus 2, we are right here. Minus 3, we are right here. So this function is going to start growing. It's increasing, and that's how it is increased. Okay. Let me note one thing, that the function f of x equals 3 to the x, that's positive for all x. What do I mean by that? 3 to the x can never take a negative value, because if you take 3, regardless which power you raise it to, if the power is negative, the number is still positive because it's 1 over 3. 3 to the minus 2, 1 over 3 squared. So 3 is always takes positive value. So, and it will never be 0. 3 to any power will never be 0. So what's the range of this function? What's the range? What are all the output value of this function? So it's never 0, and it's never negative. So what are the output value? The output value are all the positive numbers. So from 0 all the way to infinity. These are the output values. So 3 to the x is a function which is always positive. When x is take negative value, it's taking very small value, 1/3, 1 over 9, 1 over 27, and then it increases all the way. So that's the graph of 3 to the x. And it's increasing in this case because every time you're multiplying by 3, by 3, by 3, so it's increasing and increasing. All right. Now one more graph and then we summarize. So now I'm going to take the same idea. I'm going to take the graph of f of x equal. I'm going to change the b a little bit. So I'm going to take 1/2 to the power x. Okay. So let me multiply it by 4 or 10. Okay. So here a is 10 and the b is 1/2. Again, how will this affect the graph, do you think? How do you think the graph will look like in this case? I mean, it's going to be increasing or decreasing. What do you think? Is the graph going to rise or is going to fall? Decreasing. Why do you think it's going to decrease? What's going to happen here? So if I put 0, x, and f of x, and I take 0, 1, 2, and I take minus 1, minus 2. All right, at 0, I will have 10. What happened at 1? At 1, it's 10 times a half. So I'm multiplying by a half. I'm halving this value. So definitely it's going to decrease. So I'm multiplying by a number less than 1. So this is going definitely to decrease. At 2, it's 10 times a half squared. So again, I'm multiplying by a half. I'm making it even smaller. So at 2, I'm going to make it even smaller. So the function this time is really going to go down and down and down. Now at minus 1, if we do the math correctly, this is going to give me 20, which actually makes sense because the way the function is, this is going to be twice as much. Because from here to here, you take half. So the graph is going to be like this. Absolutely decreasing. Absolutely decreasing. And also, it's never 0, because if you take a half to any power, this will never be 0. If the negative power, 1/2 to the negative 1 is, so 1/2 to the negative 1 is 1/2, which is 2. So it's not a negative number. To the 1/2 to the negative 2 is 1/2 to the power 2, which is also a positive number. So the function will never take negative value and will never be equal to 0, but it is decreasing. What's causing the decreasing is that the b is less than 1. So we're always multiplying by a number less than 1. So we're making the number smaller and smaller and smaller. So the range, again, is the range is always 0 plus infinity. In other words, that the function here always positive. No matter what the x value here, it's positive regardless what the x is. So the range is from 0 to infinity. So summary for the graph of the exponential, and we should know the graph of the exponential is either like that, increases or decreases. And what decide whether it increase or decrease? So this is f of x equal a times b to the x. What's the determining factor? A is always the initial value. This is usually my a. What determines whether it's increase or increase is the b. B, if the b is bigger than 1, means I'm multiplying by a number bigger than 1, increase. So bigger than 1, the graph rises. Less than 1, it means the growth factor is less than 1, but the growth factor has to be positive. There is no negative growth factor. Then the graph falls, or the function is decreasing. So when we're sketching those graphs, we have to look at the b, and depending on the b, we know that whether increasing, decreasing. And it makes sense because in this case, we multiply by a number bigger than 1, things would get larger. Here, basically, we're multiplying by something less than 1, which make the number smaller. Okay, so this is the graph, and this is the effect of b on the graph. So this, for example, immediately, so as far as you are concerned, suppose I tell you sketch f of x equal 100 times 1.02 to the power x. I'm not asking you to sketch it extremely rigorously, but have the shape of it. So here you can say immediately, the B, the growth factor is bigger than 1. So the graph is going to rise. Initial value is 100, and the graph is going to look like that. Okay, so immediately we know the shape of the graph. The minute, if I take the same thing, but I take, for example, 0.9 to the power x. The B here, the growth factor is 0.9, which is less than 1. So the graph here is going to immediately go like that. Okay. The way you can think about it, that here, if the growth factor is 0.9, it means that's represent a quantity which is decreasing by 10%. So it's going to decrease. This one, the growth factor is 1.02. This represents something which is growing by 2%. That's another way to look at it. Okay. All right. Any questions before I move on to chapter 4? All right. So chapter 4, we're going to study something new, another function called the logarithm. Okay. Before I start defining it, let's see what's the goal of this section. I mean, why we're learning it. We're learning it for the following problem. If I tell you solve, you don't have to write, just listen a little bit. If I tell you solve the following, 2t plus 3 equal to 4. Very easy problem. We know how to solve it. We need to isolate the t. So I say, okay, this is equal to 1. I divide t equal a half. So solving this problem wasn't hard. Now, suppose I ask you to solve, I'm solving easy problem. Suppose I ask you to solve the following. T to the power 4 equal to 7. It means which t satisfies this? Okay, because we learned the fourth root, tell me, okay, t would be the fourth root of 7. And then we plug in into our calculator. So those are easy to solve. The problem that we don't know how to solve is the following. Suppose I give you the following problem. Equal to 7 now. Okay, so solve the following. It means find the value of t such that 1.0 to the power t is equal to 7. So my unknown here is an exponent. And the question is how to solve. It means how to find the t's that satisfy this equation. So the goal of this new function that we're going to talk about, which is called the logarithm, is to give us the tool, basically, to solve an equation of this form. That's really the goal of this. It gives me the tool to solve this type of equation. So we're going to start learning it a little bit today and more next week. So section 4.1, logarithm. And that's the goal. The goal is really how to solve equation where the unknown is an exponent. So section 4.1, logarithm. Right. So I start with a definition, of course, and then we will work with it. So definition. Let n, so I will try to use the same notation as in the book, let n be a positive number. Then the log of n, the log of n, which is denoted by, so we're defining a new function, a new rule, by log of n, so you don't write of, is defined by. Okay, so what's the log of n? I define it and then we work with it. So log n is to be is the power of 10 power of the number 10 that gives n. Okay, very bizarre definition, very, very bizarre. Okay, in other words, the log of n is the number that we're gonna call it a box. We're gonna call it a box. Is the number that we call it a box that has the property. The log of n is this number that has the property. If I take 10 to the power of this box, we get n back. Okay. So, in short, log n equal to a box means the following, that 10 to this power is equal to 10. Okay, so it looks like a lot of writing, a lot of stuff, but it's not very easy. Not very hard. We're gonna start working with it. So for example, a lot of examples. So we're defining a new rule, like it's a new rule that to every positive number is gonna assign something. We call it the log of this. So for example, suppose I ask you log of 100. What is the log of 100 according to my definition? Log of 100 is the thing, so that when you take 10 to the power the thing, you get 100. So log of 100 is what the thing such that you take 10 to this power, you get 100. It's the thing such that 10 to the power the thing, you get 100. So what is the log of 100? It means what is the power of 10 that gives me 100. So we're defining a new rule. Takes a number to something. So what's the log of 100? It means what's this power? I'm asking about the power. 10 to which power equal 100 is equal to 2. Since 10 to the power 2 is equal 100. That's what the log of 100 means. That's the definition of it. That's really my rule. So I'm going to give you now a bunch of stuff, bunch of terms, and I want you to evaluate their log. So it is the power. It's what we have to put here, the power of 10 that gives me 100. So I'm going to give you a bunch of examples. Please, all of you try, even if it sounds a little bit hard at the beginning, but it's not, impossible. So the following practice problems. Find the following. And I don't want any calculators because I want you to understand what this number is. Find each of the following. Okay. All right. What is the log of 10? What do I mean by that? First, I write. It means what's the power of 10 that gives me a 10? So log of 10. So we're defining a rule now. A function is we're defining a rule. And the rule is that to every number is going to assign something. We call it log 10. What's the something we assign to? We assign to it the power of 10 that gives me what we start with. So what do you think log of 10 is? Anybody agree with your classmate? Yes or not? I want answers so I can move on. Okay, Jake also agree. It's equal to 1 because to the power 1 equal to 10. Okay, now I'm going to give you a lot of others and I want all of you to give me answers. What's the log of 1? It means what's the thing such that when I take 10 to the power the thing, I get 1. Think about it. Is 10 to the power 1 over 10 equal to 1? Whenever you give an answer, ask yourself, is 10 to the power whatever you gives you a 1? If yes, you're correct. If not, you're not correct. Xavier gives me 0. Is Xavier right? What do you think? So if it gives me 0, it means Xavier is telling me 10 to the 0 equal to 1. Is he correct? Absolutely so. So log of 1 is equal to 0 because 10 to the 0 is equal to 1. Okay, so whenever you give me an answer, ask yourself, is 10 to this answer equal what's inside? Right, so let us practice a little bit more. What is the log of 1 over 10? It means, what's the thing such that when you take 10 to the power of the thing, you get 1 over 10?
-1.
-1, absolutely correct. Because 10 to the -1 by definition is 1 over 10. So this is going to be equal to -1. Okay, so that's the log. It's hard because it's defined as an exponent. So you're looking for the exponent of 10. The output of the log is the power of 10 that gives you what's inside, what gives you the input. So that's what's make it hard, because the output is the power. What should I put here? So that 10 to this power give me the input, which is 1 over 10. All right, a little bit more. Of course, log of square root of 10. Again, you have to ask yourself, okay, the output is the power of 10. That's the output of the log. It's the power of 10 that gives me that. What's the power of 10 that gives me the square root of 10? I want a lot of answers. I will not just pick whatever answer I see. I want more students to participate. Jake, Taylor, everybody, fine. So it's the power a half. Absolutely correct, because that's what this 10 to the power a half by definition is the square root. So this is equal a half because of that. All right, 2 more, and then I move on. What's the log of this? And again, I do not want a calculator, because equal to what's the thing, what's the output, such that if you take 10 to the power the thing, you get 1 over 100. So the output, so 1 over 100 is an input. The output is the power of 10 that gives you 1 over 100. So what is the power? -2. Okay, I have 1 answer. I do not accept only 1 because it may be wrong. Anybody agree? Anybody agree? What do you think? Agrees? Let's see what. 1 over 100. 100 is 10 square. 100 is 10 by 10. So 1 over 10 square, this is exactly 10 to the power -2, because that's the definition of 10 to the -2 is 1 over 10 square, and the answer is -2. And the reason is, what's the reason. All right, so I said 1 more, and then actually 2 more, sorry. What's the log of 1 over the cubic root of 10? So you guys are always putting 10 because these are the only ones you guys can compute. Otherwise, you have to use the calculator. So the question is, what is the thing? So that when you take 10 to the power the thing, you get 1 over the cubic root of 10. So you can basically, you're asking yourself, 1 over the cubic root of 10 is 10 to which power? That's really what we are doing. Please don't look up your calculator. I know your calculator can do this stuff. So my question is basically now 1 over the cubic root of 10 is 10 to which power? That's really what the question is. So let us remember a little bit. Cubic root of 10 is 10 to the power a third. That's what the cubic root of 10 when we use fractional exponent. So now 1 over 10 to the power a third is actually 10 to the minus a third. So what should go here is minus a third. That's what should go into the box. So this is equal minus a third. So the log is a function. This log is a function. So you give it an input, whatever your input you give it. So that's the log. The output is the power of 10 that gives the input. So it's a very weird definition, but it is what it is. That's why we're studying it. So you give it something, it's going to spit out a value. What spits out is the power of 10 that gives me the input back. All right, my last question along those lines is the following. What's log of minus 10? Again, what's the thing? The minus 10 is my input. My output is, what's the power of 10 that gives me minus 10? Any ideas? Any hint, any feeling for it?
Can you not do this?
Because.
The answer is a negative number.
Right. So what we're going to say, ln of a negative number is what? Absolutely undefined. Yes, absolutely undefined. Why? Because as I mentioned before, when I was sketching the graph of the exponential, if you take 10 to any power, you can never get a negative number. Undefined because 10 to any power x, regardless what the power is always positive. So no matter what you raise 10 to a power, you have to get absolutely a positive number. That's why when I started with the definition of the log, I said let n be a positive number. That's the reason we insisted that n is a positive number, because our definition doesn't make sense when the number is negative. So the first thing we can say is that log n in general is defined, or it makes sense only when n is positive. Okay, it only makes sense when the number you put inside is positive, otherwise the definition falls apart. All right, now before we we keep going, I'm going to do another practice problem like this. So when I tell you log n equal to y, basically, it means, so y represent the box that I am talking about. It means if you take 10 to the power this box, you're gonna get n back. Okay, that's really the relationship. So log n equal y, it means 10 to the y is equal to n. So with this in mind, I'm gonna ask you the following. So another set of practice problem. Okay, I'm gonna ask you the following. Rewrite, so the goal here is to start interacting with those definitions. Rewrite each equation using exponent. So I'm going to give you an equation. I want you to rewrite it so we can make sense out of it using exponent. So suppose I pick up log of 15, okay? And I pick my calculator. I take my calculator, for example, and your calculator evaluate the log. So let us see. This is log, which is the log. So I'm going to take log, sorry, I have to put it on first, log of 15. Okay, so I pick my calculator and I'm going to use the first 3 decimal. So I use the calculator because you guys will have to use that, and I get 1.176. 176. Sorry. All right, what do I mean by using it as exponent? What does the 1.176 represent? It means that the output is the power of 10 that gives you 15. That's really what it means. So when it means 1 is equal to 15. So that's what I mean using the exponent. So when I take log 15 and I get a number, what does this number? It's the power of 10 that gives me 15. So we're switching the input output. So I'm going to give you 2 problems along those lines. So suppose log of 200. So I pick my calculator and I evaluate log of 200. So I'm going to push the log button, 200. I get 2.3, first decimal place. Okay, rewrite using exponent. What do you want me to rewrite so you understand what it means? So basically, I want you to copy this, but copy it means 10. Means the 2.3 is the power that I should put here. So the output is the power of 10, which give me 200. The last example is a little bit more abstract. Suppose I tell you log of t is equal to 4. What does this mean to you? Using the exponent. Anybody else? So that's my input t. So log of this is equal to 4. What does this mean to us? So the input is t, the output is the power. So the output here is the power of t that gives me t back. So log t equal 4 basically means t is 10 to the power 4. Means if you plug in 10 to the power 4 here, you're going to get a 4. Now there are 2 kinds of logarithm function that we're going to study. So this logarithm we found, I'm talking about today, is the following. So log n, we defined it to be the thing, such that if you take 10 to the power the thing, you get n. And the question is, why 10? Why couldn't be another number? So it means, why did you pick 10? All right, 10 because we work with a decimal system, we use 10. But honestly, we don't have always to use 10. We can use other numbers. And the most important number we're going to use is the number e. So I'm going to talk a little bit about the number e. E. And E stands for Euler, which is one of the most famous mathematicians of all time. So E is a number. E is a number. And it's like the pi, the number pi that we see in geometry or trigonometry, wherever you see it. It's a number. It's one of the most important number in math. It plays a big role once you study calculus. But it's a number, no more, no less. And we can approximate this number. So it's called E, but it's a number. It's just like pi. Think of it as pi. Pi is a number, which is 3.1418. So that's the pi. E is another number, an important number in math, and it's almost equal to, and that's a good estimate, 2.71828. So that's really the number E. And the number E turns out to be an extremely useful number in math, especially in calculus. It makes math easier. It makes calculus much easier to work with. So it's a number, as simple as that. So if I tell you what's E squared, so we should not really be terrified. E squared, it means you take this number, of course, we use our calculator, and you square it. So it's actually another number. So on our calculator, we can evaluate this. So, and I take E squared. So look up your button, E squared. I get the number. I get almost 7.389, which makes sense. 389. So E is a number. That's what it is. Now we're going to define the following. The idea of the natural logarithm, which is the same thing as I did before, but instead of using 10, I'm going to use E because E of its importance. So we're going to call this something called the natural logarithm. What it is. So definition. Again, let n be a positive number. Then, the natural logarithm of n denoted by, so we're adding the word the natural logarithm, denoted by ln of n. Okay, so the natural logarithm of n, denoted by ln of n. The other one was log. We call it log. This one we usually call it ln of n, is defined by as follows. Okay, so the natural logarithm or ln of n is defined as follows. It's the same definition, but instead of 10, I'm going to use e. So ln of n is defined to be the power of e that gives n back. So instead of being the power of 10 is the power of e. In other words, ln of n is the thing, or is the number, that we call it a box, that has the property, so it's a number that has the property that if you take e to this number, I get n back. So it's the same definition, but instead of taking 10, and I start with 10 because 10 is easy number, we can interact with much easier. But ln, the natural log, is actually the one we use the most. So it's the number that has the property that e to this power is n. So ln of n equal to something means that if you take e to the power of the thing, you get n. So that's the definition of the natural log. So we saw two definitions today. One is log of n. You look for the power of 10. ln of n, we look for the power of e. So let's practice this one a little bit. And as I said, will be the one that we will use a lot because e plays an important role for us in math. So, ik practice. Find the following using the definition. So find first ln of e. What's ln of e? Okay, what does it mean? ln of e is the thing. So we input e, the output is the power of e that gives me e. Naturally, the power of e that gives me e is 1. So ln of e is equal to 1. So I'm going to start playing the same game that I played a little bit ago with the 10. So what is ln of 1? Means what's the thing? So when I take e to the power of the thing, I get 1. Okay, please now start answering the question. So what is? So this is because. Again, it's a 0. That's really the definition. E to the anything to the power 0 is 1. Okay, so let us keep working with those. What is ln of a very easy number? E to the 5. Means e to which power? Will give me 5. So the output is the thing that e to the power the thing will give me e to the 5. So very quickly, what's the answer? It's basically in front of us. E to the power 5 is going to give me a 5. All right, now let's see a little bit harder, not quite, but a little bit. What's the ln of the square root of e? Remember, e is a number, which is 2.7. So the square root of e, it means the square root of 2.7. But we always put e instead of the 2.718. But it's a number. It's not a variable. It's just a number. It's like pi, and that's important to know that. So what does it mean? What's the thing? Again, it's the same picture. Such that e to the power the thing, we get the square root of e. Okay, so I start from here. Square root of e is e to which power? That's why we study those fractional exponent. It's to which power? Square root of e is e to the power a half. So that should be to a half, and this should be a half. That means if I really pick up my calculator, that's exactly what I'm going to do. Right, so the last one is what's ln of 1 over square root of e? Means what's the thing? I have to raise e to the power to get 1 over the square root. Sage, Jake, all of you. Naki is answering. Okay, minus a half, absolutely. Right. Now, what's the ln of 0? What's the thing? E, which give me a 0. E is a number. Remember, E is a number. Don't be afraid of it. So, E is 2.718. Never lose track of that. I'm asking Q is Z. Can you find a power? So that when I take this to this power, I get a 0. What can you think? So it's not, it's just a number. So it's a number. I mean, the growth factor is 2.718. That's an exponential function whose growth factor is 2.718. So can you find a number such that if you take 2.718 to this number, you get 0? What can you say? Anybody? Absolutely indefined. Absolutely indefined. There is no number. You can take this to its power, nothing. I mean, if you take it to the power 1, 2, 3, you're not going to get 0. If you take it to the power 0, you get 1. If you take it to a negative power, like -1, when you take it to a negative, it means 1 over this, which cannot be equal to 0. So regardless which power you take, you will never get 0. So ln of 0 is absolutely indefined. Indefined. Okay, there is nothing to the power, nothing you can put here that will bring up the 0. So it's absolutely indefined. Okay, so ln of 0 doesn't make sense. Even the log of 0, it means the one with base 10, also doesn't make sense. So the log or the ln, both of them has no meaning when the input is 0. There is no output. For the same reason, if I ask you what is the ln of -1, means if I take e to which power we get -1. Remember, e is a number. E is a number. Don't lose track of that. So what do you think ln of -1 is? Ups this again undefined. Because, as I said, I repeat, if you take e, if you take it to the power 0, you get 1. If you take it to the power 1, 2, I mean, it's 2.7. 1 to the power 1 is 2.7. To the power 2, you just take it to the power 2. You multiply itself. If you take a negative power, it's 1 over it. It doesn't make it negative. It's 1 over it. So ln of -1 is absolutely undefined. So ln of n, so in general, not in general, I mean, ln of anything makes sense only if n is strictly positive. That's the domain. It means it cannot have a negative value. Okay. All right. I think the time is up, so I have to stop right here. For Tuesday, please do the homework I assigned. So you're going to have a quiz on Tuesday. Quiz about 3.1, 3.2, how to find the equation for an exponential function if you have 2 data points, and how to find 3.2 is mainly try to understand the difference between linear versus exponential, and a little bit from 4.1. So I insist that you go over the problem I will assign from 4.1 because I have to go start from there. So if you don't review this, you will be lost with me on Tuesday. And do the homework. That's the only way I do the practice. Okay, and your last Moodle homework is on so yes, you also have a Moodle homework. This will be your last homework of the semester. It's already up there, or it will be up there at 11 o'clock. It's due next Thursday, as usual. Okay, so for Tuesday, do the practice problem. You have a quiz. Your Moodle homework is already there. It's due next Thursday. All right. So any questions? The class is over. Please, any questions?